Welcome back. And before we get into the demos, this is really the block diagram of what's going on. Otherwise, you might get a bit lost. I mean, I spent quite a long time on this, and I'm not claiming it's perfect by any means. It's largely experimental in trying to get natural language to switch lights and do a whole load of things, really. And it's an illustration of how, if you take a large language model, this one's the Vicuna one, which is based on the Llama one. It's 13 billion parameters, 16K prompt, which is quite big, so you get quite nice answers out of it, and you can put quite big prompts in, although it grows quite quickly. It's similar to what I showed you before, but this is a bigger model. It's got more information on it. It needs a graphics card to run, of course, otherwise it's you never run it. But to help it along a bit, I'm using the Google speech recognition. This is one I used in translators and things in the past. So I'm using that to do the translation rather than doing it locally with the Whisper algorithm that I used before. So that goes in, natural language goes into the Vicuna, I call it the Vicuna model, which is a small large language model. Also the image thing that you've seen before, where you put an image in and it tells you about it, that goes in, but I'm not going to talk about that today because I've mentioned that before. It will reply if you ask it, what the Battle of Hastings is or whatever, and you want it to speak that, so you use text to speech. And here I can use either the Microsoft SAPI 5 or the Serproc ones, which are just the normal Windows ones, or Microsoft Edge text to speech, and that's an online. You need to be on the internet for that one, and they're pretty good because I've got so many voices on that. It means if you wanted to speak many languages, it can speak in the native tongue. What you don't want is somebody who's speaking English trying to speak French or something, which is what can happen, and it starts speaking in franglais, which can be quite amusing. But it does a check on the voice as well. It's coming out of the text, and if it's coming out in English, then that's fine. If it comes out in, say, French, then it'll switch the voice, so a native French speaker will speak, and you'll see that in the demo as well. The lighting works with, I'll show you in a minute, the specific commands. And that goes into this engine which reads the commands. It's like an interpreter, really, not a compiler, but it's an interpreter that takes the commands one by one. And it can handle, well, I'd say indefinite, but huge scripts full of them if you wanted to do complicated things. But it's very simple language, and it only does switching and delaying. And the hardware, well, why reinvent the wheel? We're just using the Philips Hue bridge, which you can buy in the shops. You can control that from Python, and that gives you a Zigbee output. And the smart lights, just buy the Philips smart lights. You can use other systems if you want to try it, like it's the one I was using before, but this has got a proper documented. A lot of the other ones are other smart systems, smart light systems. You have to kind of hack them, and people have been trying to reverse engineer them. But this one's good. I mean, it does good. It has its problems, but it's good. Okay, so the idea here is that if you issue a natural language command to like something like, could you turn the lights on, please? Normally it wouldn't be able to do that because it needs a very firm language like command, turn on all lights or something like that, and then it would have to do it. But here the Vicuna model will take it and turn it in to the proper command, hopefully. And sometimes it'll decide not to do it and just do something completely, that's how these things work. If you're not very strict with them, they can kind of wander off and do some daft things sometimes. So I'm not sure. You'd have to be very careful if you had safety issues using large language models. If it was flying a plane or something, you'd have to have real physical restrictions on it, what it's doing. Anyway, that's that. So large language model doesn't know anything about lights. So if you just told it switch light one on, could you switch the lights on, please? It'll say, I'm a large language model. I don't know anything about lights. I don't know what you're talking about. So you've got to tell it in the prompt, the system prompt that is, about the switching commands. So, but the other side of it is a large language model uses natural language processing and can convert to these domain-specific commands, which I created, basically very simple ones. Or you can enter just text in with the commands, like at a text prompt, like command light one on or whatever, and it can talk about other things. And so this is the domain-specific language. Command light X on. So command light one on would turn light one on. Command light X off. Command all lights on. I've only got 4 lights. I mean, you might not want to turn every light on a building on, of course. Command timer X. So you can set command timer 10, for example, will be 10-second timer, or 3,600 if you want, an hour, whatever. And command light status. So you can chain these commands together. So you can have command timer 20, command light 1 on, command timer 20, command light 1 off. That means wait for 20 seconds, turn on light 1, wait another 20 seconds, then turn it off again. And you can do that. So this is something you're going to see a demo of. You can make a script up. You can't use these bullet points, of course, it would mess it up. But just an ordinary text file with these commands in it. And this is, if you've got 4 lights, you can make them count in binary just for fun, just because we can. Here's the new program, guys. And before we had a web page. This is just done locally on the PC, and I've got the Google speech recognition rather than the Whisper one, so that's coming from the internet, so it is running from the internet, but I'm running the large language model in 4-bit mode locally. That's the Vicuna one, which is based on Llama. So let's just give it a go. So this is where the text comes out. This is where you talk to it. We'll just ask it a few things before we get on to anything else. I'll explain this later. That's the lights part. These are simulated lights. We've got the real lights as well, but I'll show you them later. And the transcript goes in here as well. It just comes out this bit as well. Hello, can you hear me?
Hello. Yes, I can hear you. How can I assist you today?
Well, first I'll just do it, as its normal large language model, and ask it something like, I don't know, Pythagoras' theorem or something. See if it knows about that. Can you tell me in detail about Pythagoras' theorem, please? See, it's come out here as well.
Certainly. Pythagoras' theorem is a fundamental concept in geometry, and it states that in a right triangle, the square of the length of the hypotenuse, the side opposite...
Okay, so that's your normal thing, and of course you can ask history questions as well. Tell me in detail about the Battle of Hastings. You can ask recipes and whatever. I mean, the usual sort of thing.
The Battle of Hastings was a pivotal event in English history.
You see, it gives quite a long, detailed account. This is the 16K token version, so you should get more out of it, really. So that's describing whatever you wanted to describe. Of course, it's not as smart as the latest AI. This is, still going to be, a couple of years out of date or something. But if you compare it with, what we had 5 years ago, it's amazing, really, that it's running in your home. Oh yeah, the other thing I can do, of course, is I can tell it to switch languages, which is quite interesting. Let's see if I can do that. Repeat the last answer in Spanish. Sometimes the problem is getting it back to English once you've got it, the language changes. It should switch voices if it does it properly and speak in a Spanish voice. Here we go.
Claro, aquí está la respuesta en español. La batalla de Hastings fue un evento clave en la historia inglesa, librada el 14 de octubre de 1066 entre las fuerzas.
And so the trouble is, it's expecting me to speak in Spanish now, so I'm going to have to tell it to go back to English. Speak in English. I might not have actually recognized that. I'll try it again. It's because it's probably listening for Spanish. Or it did it. It's gone back to the Battle of Hastings.
Sure. Here's the answer again in English.
So it's gone on with the Battle of Hastings. That's okay. So it's back to English again. And we can do the same sort of things, some impressive things. This is the opening of the King James's Bible, I think it is. This is the first in Hebrew. And I'm just going to, I can't speak Hebrew, so I'm just going to paste it in down here. See if it recognizes it. Oh, that's wrong. Paste. And then submit. So that's and that's got vowels in it as well, I believe, which makes it, older version of.
This passage is from the first chapter of the book of Genesis in the Hebrew Bible. It describes the creation of the world by God, including the separation of light and darkness, and
if you really wanted to, you could get it to speak it in Hebrew. Could you speak all that in Hebrew, please? Sometimes at times it takes a little while to do this, and it's also recording as well, so it's this Hebrew.
כן, הנה המליאה בעברית. בראשית ברא אלוהים את השמיים ואת הארץ. ביום השני ייתן אלוהים סביבת הארץ להבדיל בין היום ובין הלילה. ויהי ערב ויהי בוקר יום.
And so on. So it can handle a lot of language. I've only got it set up for about, I think it's 20 languages and things, but in theory it could do a lot more than that. Right, I think we should kind of move on to the light thing. So this is the light simulators. Now we've got the real lights I'm going to show you later, but these just simulate lights. So if I just toggle that, it will put this simulator on in this canvas, and it'll also put the real light on, but you won't see it anyway because I've got a screen capture thing, but you will see it later when I do it. So I've got commands which are a language, domain specific language, which just turns lights on and off and does delays and things, which you can issue, or you can put it through Vicuna, the large language model, in natural language. This is the beauty of this, and get it to do it for you, because you might not remember what the commands are, although they're pretty simple commands to remember. But if you just do a command and then I think it's light 1 on and then command light 1 off, that should turn light 1 on and off. But instead of doing that, let the large language model convert it for us and see if it will do it. Sometimes it gets it wrong, but let's try it. Could you turn light 1 on, please?
Command light 1 on.
So it's converted it into the proper command, which is command light 1 on. And I could do something like this. Turn light 2 on for 30 seconds and then turn it off again.
Command light 2 on command timer 30.
It's actually forgotten to turn it off. I said, what did I say? Turn it off again. Yeah, it's forgotten to turn it off, but it's done the 30 seconds thing, but that won't make any difference because it hasn't turned it off. So I can turn it off for it. So I can do command light 2 off, and that should Yeah, it's
Command
actually,
all lights off.
so it's converted that into convert. So sometimes it does that kind of thing. It's decided it's going to turn all the lights off. It's just made its own decision on that. But usually it's fairly accurate. Um, can you turn light 1 on and then light 2 on, please?
Command light 1 on, command light 2 on.
So it's done it one after the other, and that's okay because we can handle that syntax. We can also handle it if it's one above the other in different lines. And it's going to be quite frustrating because if you're not very, it doesn't know anything about lights, so you have to tell in the prompt about what these commands are. And sometimes even when you do that, it decides to put things in front of it. It might decide to put a quote in there, for example, in which case it doesn't work because these are fairly strict commands. And if you put command lit or something instead of light or something like that, it might not work. So you've got to allow for a whole load of different variations, and you use regex, I think it is, to do that in the Python code. So you can look, sort of take a note of all the variations and get it to handle most of them. Let's try another delay one again. Turn light 3 on for 10 seconds and then turn it off again.
Command light 3 on, command timer 10.
It still hasn't turned it off again, isn't it? It's quite annoying, that. But no, I mean, I can show you how that works. Let's turn all the lights off anyway. Command all lights off. So I'll do one
Command all lights off
for 10 seconds myself. Command light 1 on, command timer 10, command light 1 off. Oh, what's it done? I don't know why it did. Oh, it's done it. That light came on for 10. I've not seen that before. It just says process timer command sequence. And that's a complete mystery to me. I don't know why it's done that. Sometimes it has a mind of its own. And to tell you some funny stories, when I was working on this, I had to make the prompt in the earlier versions quite strong so that it could handle the natural language. And it got to the stage when I was asking it about some mathematics or some history, it came back to me and it said, "I'm sorry, I'm just a lighting computer. I can't answer questions on anything else apart from lights." So I then said, answer it, anyway, and it did answer it. But at the end of the answer, it says, "But are you sure you don't want to know anything about lights?" So it was kind of, it got into the swing of things so much. It was all it knew was about lights. Anyway, this usually works quite well, and I'm going to show you some demos of the real lights. And the other thing we can do, and I'll just show you that briefly, is we can run a script, and that's always very accurate. So just going to do one of the I think it's just this first one will just be a flashing light. Oh wait, that's not there actually. I'm going to load it. So flashlight, and it should just flashlight 1. I think it runs. So let's run it. Light 1 on and off. That's all it does. But here I've got the binary counter 1, which I talked about earlier, and I'm going to load that up, and I'm going to show you that working. I'll show you it first on the simulation. Let's load the counter up, binary counter. Let's loaded it, and let's run the script. That's just counting in binary. Now, because these lights are connected to real lights, which you can't see at the moment, the real lights are flashing on and off. This is flashing on and off, and these control real lights as well. And they do that, of course, through the Philips hue hub. Nothing to do with a guy called Hue. It's the hue of the lights that's doing it. Anyway, so I'll show you that demo, and that's about it. That's how you do it. The large language models don't really know about about lights. In fact, they don't know a lot of things. They just know about language, really. And so you have to fiddle things so that it learns about it. And if it gets things wrong, like it's doing here, it doesn't do everything right. You have to go and look at the prompt and make it stronger so that it can get it right the next time. Or you can bypass it altogether, which is what I was doing, and just use these command things. But not everybody can remember them. So hang on. Can you just turn off all the lights, please? It should be able to do that. So see, it's turned them off.
Command all lights off.
So that's a natural language. Can you just turn off all the lights? That's how I'd ask somebody, a human, to do it. Just turn off all the lights, could you please? Just turn on all the lights, please. Thanks. There, it's turned them all
Command
on.
all lights on.
Okay. Just turn off light 1, please.
Command light 1 off.
Anyway, that gives you a rough idea. So the basic concept is there. It takes a lot of fiddling. And I know that other companies and so on are working at this kind of thing. I'm pretty sure they are. And then, of course, Amazon's got Alexa, but it doesn't have a large language model at the back of it. I'm pretty sure it doesn't. I mean, it may well do now, actually, because they're probably working on that. And they'll do it a different way. They will have the toolkit from the large language model running. So you see, I'm running the large language model locally. And what you can do is you can get the SDK, the software development kit, and run it commands, and then it goes to the internet. So it goes to a powerful large language model, and perhaps do it that way. But then you need to be charged. You get charged for every token that you use. So there would have to be a charge for that, I'm afraid. A token, by the way, if you don't know, is it's a proper way to work it out. It's a rule of thumb is it's about 3/4 of a word. So if you have 16,000 tokens, you've got about what's that? 12,000 words or something like that. It's how it works out. But that's not the proper way to do it. That's just a very rough and ready way of doing it. Okay, thanks. So what you're seeing is the program. These are the light simulated lights up here. There's 4 of them. There's one actual light here and another light here. It's only 2 at the moment. And let's just do some voice commands. So let's just turn light 1 on. Could you turn light 1 on, please?
Command light 1 on.
Could you turn light 1 off, please?
Command light 1 off.
Actually, you'll see the light at the side here changing. I'll just do it again. Command light 1 on for 10 seconds and then turn it off again.
Command light 1 on.
No, that didn't actually get my command there. I'll do it again. I'll just tell it to turn off. Turn all the lights off, please.
Command all lights off.
Now what I'll do is I'll put a timer, so I'll say this. Could you turn light 1 on for 10 seconds, please, and then turn it off again?
Command light 1 on. Command timer 10. Command light 1 off.
So it should turn off any second. There it goes, it's off again. Could you turn light 1 and light 2 on, please? There's light
Command
2.
light 1 on.
Light 1 and
Command light 2 on.
Again, it's issuing the command. So that's the natural language. The proper command is command light 1 on, command light 2 on. But I'm just asking it in natural language, and it's converting it. The Vicuna AI is converting it into the actual language, so I don't have to remember everything. And if it works, it doesn't always work. We can try the status. Could you tell me the light status, please?
Sure, the current light states are, light 1 is on, light 2 is on, light 3 is off, light 4 is off.
Oh, I got it right, as you can see. And the other thing I can do is I can run a script. Okay, I've got 4 lights. Light 1 here, it's a bit dark, you can't see it. Light 2, light 3, and light 4. That gives me 4 bits of binary. See if I can zoom out a bit. And now I'm going to run the 2 to the 4, that's 16-bit counter. It should count in binary, with this being the least significant bit and this being the most significant bit. So it should go up to 1111. So let's run it. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All lights are on. I'll just run it one more time. It's initialized. 1, 2, 3, 4, 5, 8, 9, 10, 12, 13, 14, 15. And that's how you count in binary with your house lights.